Well, good afternoon, everyone. Today we're going to talk about the um, decomposition of fractions or partial fractions. And just take a little time to do some examples. I think the example in the book was maybe a little bit too big of a jump for some of you. And I don't mean that in a negative way. I just mean that it seemed a little freakish. And it's no big deal. I mean, we can say that, I don't know, say you have 1/2 plus 1/3. It's no problem to say, well, we need a common denominator. That's going to be 3/6 plus 2/6, and that equals 5/6. So let's take that 5/6 now and say that 5/6 is equal to 1/2 plus 1/3. And I know that seems like a really simplistic example, but it's really not that different from what we were doing today in class. You just had some variables. And in general, we can say that if you have some function p of x divided by some other function q of x, that we can use partial fractions if two conditions are met. We can use the method is usually what you hear. Method of partial fractions if two conditions are met. And Derek, I know I promised you I would prove this, but for now, let's just say we know that this works if two conditions are met, and I will prove it eventually, just not today. So both p of x and q of x must be polynomial functions. And basically that's saying that they're in the form ax squared plus bx to the first plus cx to the 0 plus ... like that. That looks like a 9. It should be an A. Or higher power. Could be ax to the fourth plus bx to the third plus cx to the first, etc. And condition 2, it has to be that the degree, I'm starting to use cursive, the degree of p of x must be smaller than the degree of q of x. And by that, p of x could be to a third degree a cubic, and q of x then would have to be a quartic or a quintic or a higher degree polynomial. And if you have these conditions, then you're good to go. So let's do an example that's more similar, but still maybe a little more clear than what we had today. So what would be the partial, you can impress your date with this, partial fraction decomposition for 6 over x squared minus 1. So say to yourself, do these meet the conditions that we set out here, p of x over q of x? Well, even though p of x doesn't look like a polynomial function, we can say that 6 is the same as 6x to the 0 power. So the highest degree polynomial here is 0. And then q of x is x squared, so that'll work too. It's a higher degree polynomial. Okay? So then we can say, well, this is equal to 6 over x minus 1 times x plus 1. Remember, that's one of those trinomials that factors nicely. And so then we can say, okay, 6 over x squared minus 1 equals well, I'm going to change it. I'm going to back up. I'm going to write that as 6 over x minus 1 times x plus 1. And we can say that just like our 5/6 example that we had earlier, we can say that that's equal to some a value. And we don't know it yet. We're going to find it. Plus some b value over x plus 1. And these values will be constants. And we can solve them. But right now we don't know them. And I know, Johnny, that was making you uncomfortable today. But you just got to have a little faith that using the beauty of mathematics, we can find values for a and b that make this work for all values of x. Okay? So, let's give it a shot. Just like we did in class today, we can say that this is equal to a over quantity x minus 1 times, and then you just do the other one here. But we'll multiply by 1, the multiplicative identity. X plus 1 over x plus 1. Plus some value b, and again, it's some constant that we'll find that works. We just don't know it yet. Have a little faith. Over x plus 1 times, again, the multiplicative identity, x minus 1 over quantity x minus 1. Okay, so far so good. So then let's multiply this out a little bit, try to put it together. So now we'll have a times the quantity x plus 1 over x minus 1 quantity times quantity x plus 1 plus b times the quantity x minus 1 over x plus 1 times quantity x minus 1. And I'm even going to bring down my 6 so that we don't forget that we had it. And now you'll notice that we can say 6 over x minus 1 quantity x plus 1 equals, and we can combine these two, make them look a little bit cleaner. A times x plus 1 plus b times x minus 1 over, and they all have the same denominator. So that must mean, since this denominator and this denominator are the same, that has to mean that 6 is equal to some constant a over x plus 1 plus some constant b over x minus 1. And further, and here's the cool part, that this is true for all values of x. And that's where it gets really powerful. So now you can just pick a value. I know right now I can hear your brain thinking. You're saying, yeah, but there's two unknowns. Well, there are, but remember that a is not a variable and b is not a variable. X, these are the variables. Okay? I'm going to say this is true for all values of x. And if I were really cool, I'd use the upside down a for all. But I'm not going to do it just yet. You'll see a lot of college professors do that. So we have then, let's just pick a value. It's true for all values of x, so let x equal something easy. 1. I don't know. 6 equals a times 1 plus 1 plus b times 1 minus 1. So that 6 equals 2a plus 0b. 6 equals 2a. So a equals 3. There's 1. Okay? Let's do another one. Let x equal negative 1. You see the madness here? I chose 1 here because I knew that I would be able to eliminate b temporarily. So now, what would a good number for my next one to be? What would I let x equal that would help me here? Well, you guessed it, negative 1. So let x equal negative 1. So now I have 6 equals a times negative 1 plus 1 plus b times negative 1 minus 1. And we'll get 6 equals 0a plus negative 2b. And then we get 6 equals negative 2b. And we get b equals negative 3. So, ladies and gentlemen, we can say that 6 over x minus 1 times x plus 1 could be partially decomposed into the expression 3 over x minus 1 plus negative 3 over x plus 1. If you don't believe me, check it on your calculator and graph that. I wish I had just a smidge more time, but I have a meeting to go to. So we're just 12 minutes into this. But yeah, check this on your calculator right now. Go y1 equals 6 divided by x minus 1 times x plus 1. And go y2. Do this one with a light line and do this one with a heavy line, equals 3 divided by x minus 1. You might need lots of parentheses, plus negative 3 divided by x plus 1. See if it works to check yourself. Okay, I hope that this is helpful. I hope that this gives you some food for thought and maybe generates some questions for tomorrow. All right. Thank you all, and I'll see you tomorrow. Have a good night. Get lots of sleep. Bye.